Hey, welcome everyone. Thanks very much for being here. My name's Alan Rossman. I'm the person in the orange Hawaiian shirt here waving at you. Thanks very much for being here. I'm going to share my screen and I have a few introductory slides to introduce the workshop, and then I'll turn it over to our first presenter, Rachel, who's done lots of the background work on the workshop here. Thanks, Rachel, has just put in the chat a link to a Google Drive where the presenters have put various materials. And we believe that you have access to that link in those materials. So check it out if you care to. It's fine to do that later, or you can try it now if you want. But I am going to do what I said I was going to do and share my screen. Go to slideshow view. So I hope you're seeing my title slide here. As you know, this workshop is called Introduction to Data Science Technology Tools. This workshop was organized by the Joint Committee between the American Statistical Association and the American Mathematical Association for two-year colleges. My name's Alan Rossman. I teach at Cal Poly in San Luis Obispo, California, and I'm the committee chair for this committee this year. And I have to say, our primary activity this year has been organizing this workshop. So we're very glad to see all of you here. So I'm going to briefly introduce the presenters and the specific technology tools that they'll be talking about and giving you some time to explore today. Our first presenter will be Ambika Silva, who teaches at College of the Canyons in California. She'll be giving an overview of data science, and in particular, the relevance and importance of data science for two-year colleges. After that, we will have each of the four presenters will give a 15-minute overview of their specific technology tool. Rachel Sadie from Montgomery College in Maryland will be talking about Tableau. Maria Tackett from Duke University will be talking about R. Hunter Glanz, my colleague at Cal Poly here in San Luis Obispo, will be talking about Python. And then Tyler George from Cornell College in Iowa will be talking about GitHub. The format for this workshop is I'm giving this 5-minute introduction, and then we have these 15-minute overview presentations. That will roughly be the first half of the workshop, and then we'll take a 10-minute break. And then the really fun part will come. I'm not saying these overview talks won't be fun. I'm sure they will be. But we have what we informally called in the committee play time after that. After these overview talks and after the break, we're going to ask each of you to choose a breakout room where you will have time to explore in a guided way whichever of the four technology tools you care to. So the presenter who's talking about that tool has set up some kind of activity or exploration for you to get some direct hands-on experience with that tool. We'll do that for roughly 30 minutes, and then we'll do it a second time. So if you'd like to explore two different tools, you'll have that opportunity. Or if you prefer to spend a full hour exploring one particular tool, you can choose the same breakout room for both of those sessions. And then at the end of the workshop, we'll try to reserve 15 minutes for a Q&A session back in the main room as opposed to the breakout rooms. So the only thing left for me to say in this introduction is thanks to all of you for being here and participating. Special thanks in advance to all of our presenters who are frankly doing this out of the goodness of their heart to give up their time and expertise to share with you today. And I realize that our most precious resource is time, so I appreciate all of you giving up 3 hours of your summer to be here today. But that's all I have to say by way of introducing the workshop. So let me turn it over to Ambika, who will give an overview of data science, in particular, the role of data science in two-year colleges.
Thank you, Alan. Good morning, everyone. Let me share my screen. All right, so I'm going to be talking about the overview of data science and relevance for two-year colleges. I am a two-year college instructor, so this is super important to me, and it's definitely, we're going to talk as much as we can about this. A little about me, as Alan said, I'm in College of the Canyons in Valencia. It's north of LA County. It's in LA County, but north of LA. My connection to data science, I was on the Stat Prep leadership team. That was a MA grant that was geared on modernizing statistics. So it wasn't data science in particular, but we definitely tried to encourage technology use and kind of leaning towards that direction in an introductory stats class. I was the former AMATYC data science subcommittee chair, and I'm currently a co-PI on the AMATYC grant for the two-year college data science initiatives. On a personal note, I love tabletop games, sci-fi, fantasy. I'm a huge nerd, so if you have any kind of nerdy genre, I'm probably there with you. So we have a big task for my first 15 minutes. We could spend hours talking about data science in general, even more about two-year colleges. I thought to myself, okay, we're going to give it the old college try. So I was like, where did that come from? So I looked it up. I've heard it before, and I kind of looked it up, and it said it was popularized in 1917 by a baseball player by the name of Billy Sunday, and I found the actual newspaper clipping that they used that he had done it. So, but to get started, I wanted to get, let me see if I can do it in the chat here. Hopefully this works. It's hard when you're doing presenting. I'm going to unable to send file. All right, hold on. Let me see if I can do this. I'm going to do a link in here for a word cloud. If you can go ahead and click on that, and it should have the prompt there at it, but it should be what word do you think of when you say data science? So let me see if I can share this again, because it's not popping up when I do it. Does everyone see it?
No.
No? Okay. Okay, I got a yes. Okay, good. Thank you. All right, go ahead and start doing it. Yeah, I tried sharing it again, and it did that. All right, I'm going to share my screen again. So it looks like things are popping up. And you should be able to put in a few words. I love word clouds because it kind of, I love, one, it's taking data, right? And it's taking it right away. And it kind of, I love that it does the bigger words when it starts to repeat. I see a lot of words on data science, right? There's a lot of words that happen. I see the statistics is big and programming is big, but there's a lot of words, and that's because there's a lot of components in data science. And that's definitely speaking to me in terms of what we have. I'm going to put this into my presentation slides as well, so we can see that. So I'll change it from the generic one to do that. All right. So what is data science? And I took this from, I'll put all the links at the end of mine. I'll put those links in, but you have access to it as well. It's really, to me, the combination of statistics, computer science. And I used to say, when I first started looking into to data science, I would say business, right? Because I would say stats, computer science, and business. But I really like that they've changed it to more of domain knowledge, just kind of like whatever field it is and kind of whatever that is. And I love that, but it really is using so many disciplines. And that's what makes it a little bit of an interesting topic, because especially for me in stats, I'm not a computer scientist, and I'm not, you know, a business major or anything. So it's an interesting topic for me. And I wanted to preface all this with, I'm presenting on this. I do not have a data science class. I haven't taught data science. And so I'm going to be in those presentations with the rest of you guys watching and learning. So I'm excited to hear from the rest of our presenters. So because there's so many different ones, I actually went to ChatGPT and said, can you come up with a list of what are the key components of data science? And so since I'm not the expert, hopefully that the experts in the room are going to agree or disagree with these. So statistics and probability, I feel good about that one as a stats instructor. So I'm like, yes, okay, that feels great. Programming, so we're going to be hearing more about programming like Python and R, and proficiency in those. But then it goes into a bunch of different topics that I'm not as familiar with. Data wrangling, machine learning, data visualization. Again, I feel pretty good about with that. Big data, that's something that that Stat Prep really tried to impress upon folks, was to try to use bigger data, not just small data sets. And then it goes into other topics such as data ethics and privacy, understanding the domain expertise. So like I said, I used to say business as my third part of the Venn diagram, but really it's about any industry, and every industry I tell my students are using data, right? So domain industry expertise for whatever field or industry that we're trying to talk about. And then a big component is that communication, being able to problem solve and convey it to our stakeholders about what we're trying to solve. That's a big list of topics, and it makes my head blow because that's a lot to do for data science. So for what we want to do. So then we start thinking about, well, why is this important? What do we need to do for two-year colleges, and why is it important? And of course, data science is such a rapidly evolving field. I don't know if the rest of you have noticed, but in my classes, I do have some more students coming in and saying that they're interested in data science at the two-year level. And that it's great. I love seeing that, because that means that they're starting it's starting to become more emerging. I used to say data science and they had no idea what I was talking about. And now when students come in and say they're interested in data science, that's really a good sign to me that we're seeing that out of high school and in the two-year college. Supporting local workforce needs, if it's applicable. I know a lot of folks that are doing data science and they work with their local businesses to support what's happening in their area. And then, of course, as a two-year college, accessibility for our diverse population of students. So I wanted to dive in a little bit more for this. So accessible. We have such a diverse population of students, and this, if we do data science at our two-year colleges, it gives them a pathway, and a pathway to a career that I said is growing. The employment of data scientists is projected to grow 35%. I've read that it's one of the fastest growing fields. So there's lots of employability for our students if they get into this, and we can get them excited about data science. And then for two-year colleges in particular, we want to start thinking about, do I want to do it for transfer? Do we want to have an associate's degree? Do we need a certificate program where they can hopefully find a employment right after our certificate program? So there's a lot of factors involved when I think about a program at the two-year for data science at a two-year college.
Yes.
Thank you. Okay. So challenges and considerations, of course, resources for technology, depending on what technology your college is going to use, what you're going to be using. For me, the big one is professional development. When we started doing I was part of a big push for professional development for statistics, for intro stats, in a 2012-ish, where we really tried to focus on data. We changed the way we taught our intro stats classes, and that was a big lift. And data science is not going to be any different. It's going to be big lift to try to make sure that faculty feel comfortable teaching these classes and feel that they're experts in this. Curriculum development, because this is big, right? We're not taking our intro stats class, we're doing a whole new class or a whole new program. And that's going to take a lot of, work with our curriculum department. And then the final thing is getting students involved, right? Like I said, I've had a few students that have come in and said that they're interested in data science, and that's definitely getting up, in numbers. But how do we make sure that the word is out for both what's out there after what we do with them, if it's a transfer, if it's a degree, or into the workforce. So getting student buy-in is going to be important too. I'll post these in the chat on some current data science programs. So I'll definitely put that there. But we're not alone. We just hosted in June for, like I said, I'm a co-PI on the 2-year college data science initiative for AMATYC. And we had around 60, I think it was like 58. So around 60 folks there that were there for the 2 days. And learning about how do we start a data science program. And a few of our presenters today were presenters at that one. So I'm looking forward to hearing, because they were fantastic presenters. But we're not alone. There's a lot of us looking into it. So hopefully we can start building community. We can talk about like how we can work together and get our data science programs off the ground. So it's exciting to see this happen. I'll post this again in there. So I'm gonna be hosting the 15 minutes at the end for question and answers. I did it as a Padlet because if I have a question, I may not remember later. So I wanted to have something there, so that if you have a question and you want to have it answered either to someone specific or to just in general. It's not that there. So if you have a question and want to post it here, feel free to just hold on to your questions till the end. But if you have not worked with Padlet, there should be a plus sign at the bottom right where you can kind of add something. So you can add a question in, and then we'll talk about these questions. We'll take other questions, of course, but if you have questions, you're like, you know what, I need to put a pin in this. I need to do a little post-it to kind of remember later, then go ahead and feel free to use this throughout the day. And I'll check back in with this at the end of the day when we start going over questions. All right, well, I hope we have a fantastic workshop. I'm going to hand it back to Alan to talk about what's coming up next. But I'm excited to learn. Like I said, I'm new for data science as well. So I'm looking forward to learning from our brilliant instructors, our brilliant workshop presenters. So thank you.
Thanks very much, Amika. So coming up next, we're going to have 4 overview presentations of the 4 particular data science technology tools that we thought were so important they should be the focus of the workshop. So first up, the tool is going to be Tableau. And talking about Tableau, giving an overview of Tableau, will be Rachel Sadie from Montgomery College. So take it away, please, Rachel.
Thank you. Good morning, everyone, or good afternoon, whichever the case may be. I am truly grateful for having the opportunity to do this on this large scale. It's really fun. And I just want to make a disclaimer. My position today is to work with Tableau, but also I am a fan of all the tools that we are presenting today. So that's just my disclaimer, because I want to make sure everyone understands that I believe in all of them. I'm going to share my screen. Okay, so can you all see this in my slides? Okay, great. So Tableau, I'm actually just going to talk about Tableau Public. And I just want to start my timer so that I don't go over. Give me 1 second. Okay, so data science, I'm going to start with a high level. It's not just for the tech sector. And I actually stole these slides from Zurich Drozda. I don't know if anyone knows Zurich from Data Science for Everyone, but this is a share of job posting listings that list at least one data science skill. And I just thought I'd give this because I think it's so interesting. And this isn't everything, but you can see utilities, manufacturing, agriculture, forestry, fishing, hunting, blah, blah, blah. They're all over the place. And as Ambika said, we're talking about accessibility. How can we make data science accessible to anyone in any domain? And this was also one of the things he shared, which is from Burning Glass, which you may all know is where they're looking at jobs matching skills with academia. So skill search in data analysis. Sorry, some of the Zoom tools are in the way. So if you notice, growth and proliferation of the selected skills. So there's algorithms, analytics, AI, big data. If you go down this entire list, sorry, lost it again. Notice that coding is not included in any of those lists. I'll go back just to prove it to you. Nowhere does it say coding. So that gets me to Tableau. So not only was coding not on the top skills list, but the sectors needing data science are everything, everywhere, possibly all at once, if you get that reference. But that's why I'm making my case today for learning Tableau, because you do not need any sort of coding skills to be able to create visualization, statistical analyses. So I just thought I'd go through some of the strengths and weaknesses. So strengths, especially with Tableau Public, it is free to use. It's got impressive visualization capabilities that you can learn relatively quickly. There is no coding, as I mentioned. It's mobile friendly. You could do it on a tablet. You could do it on a Chromebook. There is a thriving community forum, which I'll share with anyone who would like to see. You can just basically search Tableau public galleries, and they're just amazing. What some of the people have done. And this I didn't know, but I learned this. Tableau Public has the world's largest repository of data visualizations, which is pretty cool. Now, on the other hand, there are some limitations. The Tableau Public has data limits. And this is the biggest thing. It's called Tableau Public because if you post to Tableau Public, your work is public, which means that you would never want to do anything that has data privacy in it or anything like that. And the one we're going to do in this workshop is even lower level. We're going to use the web authoring as opposed to downloading the desktop version. And so basically, there are all different levels of tools available in Tableau, but we're going to use the lowest level. We're going to do some web authoring, which means as long as you have an internet, as long as you're connected to the internet, you can use Tableau, but it's going to limit the number of capabilities. And then I just thought, just because I would give you a little overview, I wanted to show you a few of the visualizations that either I or and students have made. So this first one that we're going to view, I actually shared with a potential partner yesterday. So this part, I was making a plug for trying to make a capstone partnership with an organization in my county called A Wider Circle. What they do is they essentially they gather furniture to disseminate to people in the community in need of furniture. And so we were just talking yesterday as an initial talk, and I said, well, let me just show you what is possible. So this visualization I actually did with my daughter many years ago, who does not know anything about data science or Tableau or anything. She had data, she wanted it for a project, and I said, well, let's just try this. So this is a picture of Montgomery County, Maryland, where we live. And I went to the Census Bureau for the high school district shape files. They're polygons around all of the different high schools. And what you can see off on the right-hand side is we made a color legend for plurality of race. There was no majority race anywhere in any of the high school districts. But when we did plurality, what we found is these interesting swaths around the county. So for example, if you notice this gray swath around here is all predominantly Hispanic Latinx. Over here, kind of around these edges is predominantly white. This swath, which is right around our major highway, is more evenly distributed for different races. The other thing we added 2 more layers. We added the percent graduation rate as a heat map on the bubbles. So the lower the graduation rate, the lighter the color of these bubbles, and the brighter, the more intense is the higher the graduation rate. And then I'll add in one more thing so we can look at it together, but the FARMS is an acronym for free and reduced meals, and that's a proxy for income level. We didn't have income data at that time. I mean, I could have gotten it, but we didn't do that. And so if you can see, the larger the bubble, that means that the higher the need for that government assistance of free and reduced meals. So what you can clearly see is in this area right in here, we have the lightest bubble, so the lowest graduation rates in the county, in this Hispanic Latinx area, and also the largest bubbles, meaning the highest government need, which really indicates to me that there's a huge inequity in our county. So that was just one visualization that we created. I'm going to go to this one, actually. I'm mapping monkeypox, because this one, just so you can understand how easy it is to use Tableau, 2 summers ago, I was working with a number of high school students who just came in for, it's called the Summarize Experience. And I just took 30 minutes, like what I'm going to do with you all. And I said, what would you like to do? So I didn't even have anything ready. And at the time, if you remember, 2 years ago, monkeypox was on the rise, and they wanted to look at where monkeypox was increasing. So within 30 minutes, we got on to the CDC website. We gathered the data about number of cases of monkeypox. We plotted them on this US map. And at that time, we actually, the only thing that was different is I think we converted all of the abbreviations to full state names. I can't remember what we did. But within 30 minutes, all those students were able to go into the CDC, gather the data, and pop this data directly on this map. So I just wanted to show how the ease of this tool. Let me show you this one, because this is similar to what I might be showing today, but not exactly. This is an animation of neonatal deaths. So neonatal deaths means it's defined I think it's by the World Bank. They define it as deaths in the first 28 days of life. And so just to explain, this is actually a dashboard, and a dashboard means there are multiple visualizations all together. So on the left, what you see is there's a, this is, if you've ever seen Gapminder, this is very Gapminder-esque. So you can see on the horizontal axis, it's GDP per capita. On the y-axis, we have neonatal death rate per 1,000 births. This is showing that in 1995, the size of the bubble is the size of the population. And again, there's this mouse over tool capabilities of giving you a lot more information. But also, if you notice, that's 1995, but I can animate it. And it's going to go slowly, but we could watch over time this change, meaning everything is going down to the right. As GDP is increasing, neonatal deaths for all populations globally is going down over time. And that's a really fun capability. And this map is the legend of the regions. So I'm going to stop there. But that is my plug for you all. If you would like to join me, I will be doing 2 separate sessions using World Bank data, but we're not going to do anything like that. But if anyone wants any of the additional ideas, I'm happy to do that with you. So thank you.
Thanks very much, Rachel. So our next tool will be R, and the presenter for this tool will be Maria Tackett from Duke University. So please take it away, Maria.
Great, thank you. I put a link to my slides in the chat if you want to see the slides as they appear on the web browser, and then there'll also be a PDF of the slides in the workshop Google Drive. I will say before I get started, these slides were made using Quarto inside of R and RStudio. I'll talk a little bit about what that is towards the end, but just wanted to give you an idea of what it might look like if you used R to develop some teaching materials. So today I'm going to talk about teaching data science with R. So I'll start by just kind of orienting us around like what R is and RStudio and Quarto and sort of all the different terms. I'll show some examples from assignments from an introductory data science course, and then kind of wrap up with like how students can access R, etc. So when I think about the computing toolkit, we have R, RStudio, and Quarto, again, which I'll explain all of these throughout the presentation. And so just to kind of orient us, R is a statistical programming language, and RStudio is a convenient interface to interact with R. So it's an integrated develop environment or an IDE. And so the Modern Dive textbook has a really useful way to think about the difference between R and RStudio, because often these terms are sort of used interchangeably. I often use them interchangeably, where if you think about a car, R is like the engine and sort of what's underneath the hood. So it's kind of like what's making the car work, right? That's all the tooling underneath. And then RStudio is like the dashboard, the steering wheel inside of the car, sort of like how you're actually interfacing with all the machinery in the engine of the car. So again, I often use them sort of interchangeably because with my students, we always use R through RStudio. And so here's just an idea of what the RStudio interface looks like. And so from a student perspective, when they go to do their assignments or their in-class activities, they open up RStudio, and this is similar to something that they would typically see. And I won't go into this in too much detail, but again, just to kind of orient ourselves, over in the top left corner, this is our source editor. So this is where you're actually like writing things. So this is where students are writing their code. You can see this bike share code. They're writing their narrative, where they're sort of writing their conclusions from the analysis, writing some sort of text to contextualize their results. Down in the bottom left-hand corner is the console. This is what I think of as like the sandbox, where you're kind of just like playing around with things, you're trying things, but it's not what you're going to turn in for your work. Up in the top right-hand corner is your environment. This is also where, if your students are using GitHub, which Tyler will talk about later on, this is where they can interact with GitHub in a point-and-click way, so you don't have to teach Git commands. And then finally, down here in the bottom right corner is where you can see all the files. This is also where you can preview your work, etc. So if you come to the session, we'll look at this in a lot more detail, but again, just wanted to sort of orient us around what R and RStudio looks like if our students were using it. And so now I'll share some examples of like what students can produce using R. These are all from an introductory data science course that we teach at Duke. This course has no coding or no statistics prerequisite. So the students can come in having never touched a computing language before, having never seen statistics before. So we teach using the tidyverse. So the tidyverse is basically a collection of R packages that are designed specifically for data science. The nice thing about the collection of R packages, where a package is really just what holds the functions for R, is that they have sort of an underlying design philosophy, grammar, and data structure. And so basically what this means is that the syntax is pretty consistent throughout all of the tidyverse packages. And so what students learn on the first couple of weeks of their intro data science course, where they're first getting introduced to these tools, they carry this on as they continue to do more advanced things throughout the course or perhaps in subsequent courses. The other nice thing about the tidyverse is that it includes pretty much anything you would need for an introductory course. So you have a data visualing tool, you have a data wrangling tool, you have a tool that works with strings, data tidying, so how do we organize our data so that it's usable for analysis. So really there's more here than probably what you need for an introductory course, but it's nice because everything's kind of all wrapped up in this tidyverse wrapping here. So this first example is, again, just an example of data visualization. And so this was from a homework assignment in which students were analyzing data from the NC Courage soccer team. This is our professional women's team in North Carolina. And part of this assignment, they were tasked with creating a bar plot in which we wanted to look at the distribution of results. So what proportion of the time did they win the game, lose a game, or tie a game, and how that differed across season. And so here's an example of what some R code might look like, where this sort of first piece that's highlighted is really where they're just creating like the bones of the plot. So this is where they're telling R, I want to make a stacked bar plot. Here are the variables that I want to use. And really, they could stop right there and end up with a perfectly usable plot. The nice thing is it's really easy to then continue to, oh, sorry about that, I hit the weird button here. I continue to customize. So here is where they are adding labels. So here they're sort of going from our basic visualization now to making it something that's presentable and useful for a general or professional audience. So they're adding a title, subtitles, perhaps they're labeling the axes. And then this last piece here is where they're able to take it a step further. So one of the things that we talk about in our introductory course is starting to think about accessibility. And so R makes it really easy to include through one line of code, turning our plot into using a color palette that would be colorblind accessible. And so this Veritas package has a series of color palettes that is accessible to those with some sort of color blindness. And so this looks like perhaps, we have 6 lines of code here to produce this plot. This is a plot that's on one of the first homeworks. And so we start with data visualization in our courses. So by about the second, third week of the semester, students are very routine in creating something like this. The next piece here is data wrangling. And so this was an assignment from our data science course in which students analyzed data from the Bob Ross's TV show. So it was data that where you could look at all the different elements of the paintings that were created on every episode of the show. And so one of the things that they investigated was that, Bob Ross has a reputation of painting happy little trees. And so we wanted to see, well, did he actually paint more trees on his show than like the other painters who were guest stars on the show? And so they started with their Bob Ross data set. That's what we named the data, reading it in. And we said we wanted to group by this variable. So we want to do a separate calculation if Bob Ross did the painting versus if some other guest star painter did the painting. We wanted to count how many of the paintings had trees in them. And then we wanted to calculate, well, out of all the paintings Bob Ross did, what proportion had trees? And out of all the paintings a guest star did, what proportion had trees? And then here, this last filter statement is just to clean it up because all we were interested in were the ones that had trees. And what we see here, right, is we actually were able to quantify the answer to this question, again, with just a few lines of code, where in 90% of the paintings Bob Ross did, they contained a tree, and in 72% of the paintings by a guest star contained a tree. So Bob Ross, in fact, did live up to his reputation of being known for his happy little trees. Again, this is code that students learned very early on in the semester. And again, they're able to sort of take this data and answer some sort of, in this case, perhaps a random question, but again, do some sort of data analysis to investigate an analysis question. A last example here is modeling. So one thing we spend a lot of time on in our data science course is we do linear regression modeling. We talk about predictions. This is a data science course. We primarily focus on prediction. We also do a little bit of logistic regression. So here's an example of data that students were analyzing, looking at the relationship between sex and age and height for children, I think like ages like 8 to 17 or something like that. And so here, this first line here is an example of what the code would look like to produce a linear model. So this is where we're telling R, okay, we want to fit a regression line. But then students are asked to display the model output. So these next 2 lines take the model output, which is sort of like all this sort of messy stuff that's sitting inside of R into, again, something that's presentable. We have this nice, neat table that we can include in a presentation, we can include in a report, but also in line 2, by tidying it, where we say tidy, the name of our model, now we're able to then use it more easily in subsequent calculations, again, doing like prediction, if we want to do some sort of simulation-based inference on the coefficients, etc. And so this is an example of what the linear regression code might look like using R in our intro course. So those are just a few examples, again, just to kind of orient us and give us an idea of what this looks like. Again, all of this is in an introductory course. And so those are like the analysis pieces, and all of this gets put together inside what are known as Quarto documents. Now, if you're familiar with R Markdown, Quarto is basically the exact same thing. It's considered the next generation R Markdown. So the students produce all of their work in these neat Quarto documents where these sort of grayed out areas are where they write their code. And then again, in the white space here is where they write the narrative. And then up here in the YAML, this is just some metadata like the title, the date, what type of document you want to produce, etc. And so the nice thing about these Quarto documents is when they click this render button, they can run everything from top to bottom. And in this case, we're producing a PDF. So it's going to run all of the code. It's going to produce all of the narrative. And so students are very easily and quickly able to create a professional looking document that's ready to present, but also is fully reproducible, meaning each time they're clicking this button, they're getting the exact same results. So we reduce errors from students doing analysis in one place, copying and pasting it in another place, etc. And so again, this is typically how students then would sort of put all those analysis pieces that we just saw together to produce like a homework assignment, a computing lab, even an in-class activity. Again, and we'll see an example of this in the breakout session. And so just a few notes on teaching with R. So like, how do students access R in RStudio? There's two essentially basic ways. So R is free to install. So you can do a free local installation on a laptop or desktop. The advantage of this, it's free. The major disadvantages is this requires every student to have reliable access to their laptop or desktop. Also, I have used this method before in a course, and unless you're an expert in PC and Mac, perhaps you may spend more time troubleshooting computers than you might want to. I know nothing about PCs, and I learned that very, very quickly trying to troubleshoot PC issues using this method. So there are some web-based ways you can access R. So the first is through a centralized RStudio server that's maintained by the institution. This is what we do at Duke. So our Office of Information Technology has an R server. You can get a free educational RStudio license. And so the students then interact with R by logging into a web browser using their Duke credentials, and they have that full RStudio interface and capability like you saw through the slides. This is really nice because since the people who maintain this are within the institution, they're very easy to access if we want to customize things or change things, but this does require some sort of IT expert or IT team in order to maintain this. The next is Posit Cloud. So Posit was formerly known as RStudio. Now they're called Posit. And this is, again, a web-based interface, but this is maintained by Posit. So the nice thing is that you don't need the IT experts at your institution because they're all at Posit. I guess, downside to that is then you have to contact someone outside of the university in order to make changes or something like that. We'll actually use Posit Cloud today in our demonstration. But again, similar to the RStudio server, students will just log in through a URL and they have full functionality with R. These are nice because, again, students only need like anything that can access the internet. And then from the instructor point of view, everyone's RStudio experience is exactly the same. So you're no longer dealing with that PC versus Mac or what version of operating system type issue. So I'll just kind of finish up with, like, again, why teach R? And really, similar to Rachel, I'm a fan of all of the tools that are being presented today. And so really a lot of the benefits apply. Any one of us could have said any of these and probably will repeat these. And so by teaching R, we're giving students the opportunity to develop computing skills to work with complex, messy, and non-standard data. So I didn't show it here, but students can also, in our intro class, they do spatial visualization, they work with text data. Again, students are able to very quickly from the beginning produce professional data science reports. And as they're learning data science, they're already developing those skills and practices of developing a reproducible workflow. So it really just becomes part of their practice. And these tools are widely used throughout academia and industry. Students can access R in RStudio after the course, so you're giving them tools that they're able to use after the semester ends. And then for the instructor, you can use RStudio and Quarto for your work. So I use Quarto and RStudio to make all my teaching materials, websites, you can write books, etc. And this is a really nice way to sort of stay on top of what your students are doing, because you're using the exact same computing tools that then you're teaching your students. So I'll end right there. I have a bunch of resources there. And then also, if you're curious about the full assignments and the examples I showed, I have links to those as well. But thank you, and I look forward to the breakout sessions.
Thanks very much, Maria. Let me remind everybody, if you're thinking as you watch these overviews, if you're thinking, this looks great, I'd like to play myself, well, that's what the breakout sessions coming up are for. You'll get to choose 2 breakout sessions to get direct hands-on experience with 1 or 2 of these tools. Also, if you have specific questions about the tools, we're not going to take questions now, I'm afraid, but you can ask those questions in the breakout room, or you can ask them at the end of the workshop when we have 15-minute Q&A back in the main room here. 2 more tools to come. The next tool will be Python. If you're asking yourself, what's Python? Well, you're in the right place. You're going to find out what Python is all about from Hunter Glanz. So take it away, Hunter.
All right, thank you very much. I'm going to go ahead and share my screen too. Actually, let's do. Okay. All right, so a little bit of an introduction about myself as well. I didn't ask to go 3rd, but I especially enjoy it because I get to reiterate all my favorite parts of what Maria and Rachel said. So this is really great. I've been at Cal Poly for 10 years, and I've taught data science and statistical computing, computing with data at a lot of different levels in a lot of different ways. That's really the first thing I'll reiterate, I guess, is like Maria and Rachel, I like all the tools. I just like working with data on the computer. It doesn't really matter what. So I love R. I love Python. I've also taught SAS, if you're familiar with that software tool. But really anything on the computer is fun for me. And I like to try and make it fun for students. So yeah, if you're interested and curious about Python, then that's what I'm excited to share with you today. Similar to Python itself, my overview here is going to be very general and high level, as opposed to kind of the examples I think we just saw about Tableau and R. If you're not familiar with Python, it is a general purpose programming language, which actually means that it wasn't quite built for data science originally, unlike, I think, tools like Tableau and R. So in my experience, R was kind of a statistical programming language, a language and tool built for working with data and doing statistics, whereas Python was originally built and is still used today to do many, many non-data science things. So if your knowledge or experience about Python involved that detail, then I think it can seem a little bit scarier because it's more of a general purpose language. It doesn't kind of look as nice or as neat maybe to you as a lot of that R code did that Maria presented or that you've seen in other places. But I'm still here to tell you that a lot of the Python code for data science is very readable, I think is very nice, and is very accessible. Similar to R, Python is open source, so it's free to use, free to work with. And despite being a general purpose programming language, the syntax, again, I think is very accessible and readable. As an example that I'm going to return to, and that if you come to my breakout, you'll see in detail, I wanted to show you this. So just as an example here of code that is readable, right? Everything here should do what it reads as is. And that's mostly the case in my experience with R code. It's the case with most of the Python code that I work with for doing data science. So we're importing packages or libraries in Python here at the top. We're loading a data set here. We're describing a data set. There's no output displayed here, but I just wanted to show off the syntax a little bit, and I'll come back to this screenshot a few times. But it's a nice feature of tools like R and Python that the code is very readable, as in like English readable. So how do you access Python? You may have heard a variety of things about this. You may have heard the term Python distribution before, and these terms shouldn't be scary. I want to try to demystify some of these things for you. But there are Python distributions. You shouldn't have to really worry about that too much, in large part because Anaconda, I think, is what you'll probably be recommended or pushed towards when it comes to Python and installing it on your local machine. So Anaconda is the name of a very, very popular and well-established distribution of Python. It's free to download and work with. And so that's what I would encourage you check out if you want to install and run Python on your local machine. So that link's here. If you just go to python.org, there's tons of documentation and resources for getting started. And on that site, they even walk you through kind of what the different distributions are, what might go into your selection process for choosing a distribution, and other things like that. And so I've left that link here for you to get started with as well. But that's if you want to install and run things locally. I'll come back to that detail here in a few slides when I talk about an alternative. But for now, I'll be talking about running and working with Python on your local machine or on a student's local machine, either a laptop or a desktop. Once you have Python installed, how do you actually write code and work with it? Old school via text files or a text editor. So many of us, I would guess, when you took Computer Science 1 way back in the day, at least when I did, it was with C++. I think before that, it was probably C, maybe Fortran. People on the call probably have a variety of different experiences with, Computer Science 1 as a course. With those languages, you were probably writing code in some kind of text file and then using some other kind of tool or command line code to actually run those files. Python can work similarly. So you can open up a new file in Notepad or TextEdit, depending on what device you're working on. You can write Python code in that file, save it as a .py file, and then use the command line or the terminal to run the code in that file. In maybe intense data science jobs where you're running code remotely and things like that, this might be how things get run. But I'll be honest, I've never used this method myself. So this is still possible. This is still how Python code can be run, or how you may have run Python code or similar code in your past. But it's not really what I've done. It's not really what we're going to do today or what I think students will do. I'll mention while I'm kind of on this old school slide here that in my experience nowadays, students are taking CS1 or Computer Science 1 in Python in a lot of places. So whereas I took Computer Science 1 and C++, well, not as a choice. My first computer science course was in C++. I think those first courses in computer science are becoming more and more in Python. That may not be the case everywhere, but it is the case at Cal Poly. And I would guess it's the case in many other places as well. So it's likely, or you could check it out, that students have seen Python in a non-data science context or non-data context even before entering your class if they've taken Computer Science 1. We like to think here at Cal Poly that students having taken CS1 now have kind of exposure to Python. I don't completely count that because they're not necessarily they're usually not working with data in Python in a Computer Science 1 course, right? Even though they get experience and practice with Python syntax and code. But I just wanted to put that out there because I think that's more and more the case these days. Okay, if you're not writing a .py file, then where are you working with Python? Maria introduced the IDE term, so I don't have to reintroduce that, but IDEs are ubiquitous now, I think, for writing code in my experience. Whether it's Python or R or any other kind of code, you're probably using some kind of tool on top of that language, that coding language, to do all of that work. The reason is it's just a better time to be alive right now, honestly. We have better tools than Notepad and TextEdit and, syntax that looks just black and white. There are all these tools, in particular IDEs, that enhance the programming experience, that make it easier, less error prone, all this kind of stuff, which includes color coding the syntax, formatting it well. We're going to see today too in the breakout tab completion of code. So filling in variable names and other things like that. These are ridiculously amazing. And if you remember your first computer science class, maybe many years ago, it's wild how much better it is today than way back then. There are a ton of IDE options for Python, similar to R or any language really. A few of the popular ones that I've worked with myself in the past, I've heard students using, are PyCharm, Spider. There are many to choose from. Oftentimes it's personal preference, so something you like for particular reasons. We'll see here in a few slides that I'm going to recommend a different type of IDE, more along the lines of the Quarto that Maria talked about, but not quite that. So. Okay, so just to come back to this screenshot in light of IDEs that I just mentioned. So this is a screenshot of, again, Python code from one of the IDEs we're going to discuss and see today. And what you're already seeing is color coding of the syntax. And this is automatic. So the IDE has built into it how to color certain types of code or syntax in different languages, which makes, again, typing it, reading it, debugging it that much easier. You can see parentheses are in a particular color. Different types of syntax here are in white versus, say, a pink or purple color. Comments, so text here that's not actual code is in green. So this is the text after a hash. And then we're seeing a variable referenced from this data set inside square brackets here down below. That's also a different color. So it's just nice to have these visual indicators for different things in your code so that you know what's going on, so that you can easily kind of track, monitor, explore, and understand what's going on. The interface that we saw Maria introduce and that I'm going to strongly endorse as well is the notebook interface. So especially when it comes to teaching data science and teaching computing with data, the notebook interface is amazing. And I think a lot of data science gets done in notebook interfaces in general. But I will say that it's not exclusively the interface that is used for data science. I think when you want to combine text, so narrative text, like we saw Maria talk about, code and output into a single kind of publication-ready document or nice reproducible report, then a notebook interface is going to be perfect. And this is a lot of what we do as educators, and we have students do and things like that. For people doing lots and lots of coding on a job at a company, they may be coding or working with data in software and not have a need for a particular task to include any narrative text, in which case a notebook interface may be excessive. So it's not a, it's not the kind of next generation of all the interfaces really, but it is a very, very good interface for students to work in. Okay, so this is at least in my experience, a relatively new interface for working with code. Like you saw Maria talk about, and like I'll say here, this is a combination of narrative text, runnable code, and output all in the same place. Okay. You've probably heard the term, you may have heard the term Jupyter notebooks. This is probably one of the earliest, and in my experience, it was the first kind of form of a notebook interface for Python originally. So back in the day, it was originally called an IPython notebook. That's still the file extension, actually. But now they're kind of referred to as Jupyter notebooks. And the whole idea here was, let's create these dynamic documents. They've got runnable code. We can hit a button and produce output inline, and then interweave narrative text. And I'll always remember kind of this quote from one of the founders, who actually was a physics faculty here at Cal Poly. The goal here was to minimize the distance between thought and result when coding with data, right? We want to be able to explore and put results and everything together easily and well. So what are notebook options if this is what you're going to go with, which again, I think we all maybe would heavily endorse. Jupyter notebooks come for free. So Jupyter is kind of an extra installation or tool. That installation comes for free if you go with the Anaconda distribution of Python, which is nice. So that's something that's easy to set up and work with on your personal machine. I think part of the reason our Studio transitioned to Posit was because they allow Python code. Not just R. So R Markdown and the Quarto documents that Maria mentioned can run Python code. You can run and use Python within the RStudio IDE and within R Markdown and Quarto documents. So if you like that interface, or you want to mix and match between R and Python at all, then you can absolutely do that. Google Colab can also run both R and Python. In my breakout room today, and the screenshot you've been seeing is from a Google Colab notebook. Google Colab is a part of the suite of Google Cloud tools, so it's also free to use. I'm a huge fan of Google Colab, again, because it's web-based and it doesn't take any setup, similar to Maria's pitch for Posit Cloud and that online kind of interface and hosting that Posit does. Google Colab is hosted online, not by you, so you don't really have to worry about all of that. And just like Google Docs and Google Sheets, students can just share a link to a Google Colab notebook with you as a submission if they want, as one possible way to submit, their work. And again, you can run R or Python code in Google Colab, so that's really nice. I'll kind of finish here with think back to Maria's last 3 slides, and it's all the same for Python as far as I'm concerned. Like, why teach it? Reproducible data science is so much easier when you're writing code and putting it in some kind of notebook form that you can pass between teammates, peers, collaborators, all that kind of stuff. And so I'm a huge, huge supporter of writing code to do data science, even though all of the tools are great. And if you come and play around in Google Colab today with me, you're going to see that the AI-assisted tab completion is bonkers good. And so if you want to include Python or R in your course, but you really don't want to teach programming necessarily or make that like a learning outcome, then you could still use Python or R in your course and Colab, as far as I'm concerned. And it has never been a smaller barrier to working with code than it is today. It's just amazing to me. But maybe I'm easily amazed. So, okay, my last slide is the link to our activity. So if you don't join my breakout room today, but you're still interested in all the Python stuff, the last slide is the link you'll need for those materials. But I'll go ahead and stop there and pass it back to our host. Thank you.
Thanks very much, Hunter. And remember, you have access to the presenter's slides through the Google folder that we've been putting in the chat occasionally. There again in a couple of minutes here. One more tool, and remember what comes next after Tyler's 15-minute overview of GitHub. What comes next will be a 10-minute break, but then you get to choose which of these tools you want to learn more about and get some hands-on experience with. So playtime coming up after break and after Tyler's presentation. But I'm getting ahead of myself. Let me introduce Tyler George from Cornell College in Iowa. We'll be talking about our 4th technology tool today, which is GitHub. So please take it away, Tyler.
Good morning / afternoon, everyone. And like the others have said, I enjoy all these tools too. So today I got to choose well, I kind of got to choose. I ranked my choices and I got GitHub. So here we are. I'm going to share my screen and a couple links here for you all. So the first is, I'll start talking a little slower, is a link to my slides. And share my screen here. Here we go. Awesome. Make sure everything looks good. Should be viewable and full screen. All right. So unlike the other presenters though today, I'm going to do things in a little bit of a different order. Rather than talk about the tool and then say why you should use it, I'm going to hopefully motivate why we even care to even think about Git and GitHub. And the workshop title, this part of the workshop is actually just GitHub, but as you'll learn, GitHub uses Git, and so they do go together. Okay, so why? So what do you name your file name when you're starting a project? And you may notice a couple typos through here. Those are, in this case, intentional, as you'll learn about if you come to my workshop today. You'll have to help me fix them, right? So what do you name your file name? You're writing an R script or a Python script or a Word document even. What do you name your file? Well, have your students ever named their files in maybe somewhat strange names or names that they turn in a file and you're pretty confused in why they would name their file that way? Okay, so 3 years ago, I oversaw 3 students doing some summer research with me on COVID-19 data. It was 2021, so it was in the middle of it. And that's what, of course, they were interested in because it was happening all around us. So some of their file names that they chose included the following. So this is one of their tables. I actually went back and looked at some old files. Fake variable importance table. I'm not really quite sure what fake meant. Did it mean it was like old, not trustworthy? Did they make it up? I really wasn't sure. They named one of their R files the final R script. I guess they thought it was the final, but it actually wasn't the final, so it was wrong. So then they named the next one finally my last R script. Okay, well, surprise, surprise, it still was not their last R script. They were really motivated to be done with the project, but they were not that fortunate. So the next one, another file named the last R script, and this continued. You might realize already why this is a problem, but what is wrong with this? And more specifically, in the chat, I see all of you using the chat, which is great. Just put in the chat quickly what you think might be, or what types of problems would arise from this, doing this later in the project. You know, what problems does this create? Just what do you think happened later in the project? The students continued this project going into the following academic year. Yeah. Bad file names, creating confusion. They don't know which one they should use. This is a 3-person group as well. So they were not all working on the same scripts. So yeah, a lot of confusion. And what kind of outcomes do you think that led to later? Do you think this led to, let's say, good research, bad research, trustworthy research? Yeah, mixed research, bad research, yes. Okay, so of course, at the time, I was slightly amused. I can find amusement in most things in life, but it did lead to bad outcomes. And actually, it led to really the worst possible outcomes. The team members didn't know what script file had what in it. They didn't know what files did what and what parts of those files did what. There was some comments in their code, which is great, but one student would come in and work on one thing, and for whatever reason, they thought they should start a new script, and there was a lot of duplicate information. They confused versions of the data, the scripts, and the papers. They had versions of their papers that they didn't even name with version numbers. One person names their paper, you know, the final project paper, and another person names it like introduction. Well, the final project paper includes the introduction, so why are there separate files? The data was one of the most problematic. They had clean data. We had 4 different data sources coming in for this project, including CDC data. And they had versions of that data that had been merged and joined with others over time and cleaned and not cleaned in various ways. And they built models on old variants of that data. So when it came to modeling, they ended their summer project with really a clean data set. And then they continued capstone projects with modeling. And unfortunately, they built models that took days to fit on the wrong data. And they didn't realize it till several months later when the next student was working on their final senior project. Right, so I'd say that is about the worst possible outcome because, well, we couldn't trust anything they did really in the end. So some important components of good analyses. Reproducibility. This word was already mentioned, I think, by all three previous presenters. The work has to be reproducible, and in order for it to be reproducible, we need good namings. And specifically in this case, we really needed version control, is what we would say. We needed names, and the files needed to be in places that people could follow and made sense, and that when you were creating a new file, maybe there is a good reason to create a new one. It had either at least a README of what those different files were doing, or maybe just the version number at the end would have been sufficient in this case. They also needed a lot better collaboration because the three students, though they worked together over the summer, after the summer, they worked at different times on the project. And so they didn't really, the collaboration was, well, what's in the Google Drive folder? That's where everything was kept. And unfortunately, that was not sufficient for them to know what the other student had done 1 month prior. So this leads me into using Git and GitHub. I'm keeping an eye on time here. Okay. So what is Git? So I need to start with Git before we get to GitHub. And Git, by their definition, is a free open source distributed version control system designed to handle everything from small to large projects with speed and efficiency. Yes, it's a bit of a sales pitch because they want people to use their product. But it does very accurately describe why we are maybe going to want to use it. It's free, it's open source, it's a version control system. That's what we're going to move forward with Git. It is also a software. Okay, meaning that it's installed or can be installed on your computer. You may not need it. You may never use it in this way. But it is, if you want to use Git, you can use Git on its own. You will need to install it, and it will be used in a console or a terminal. Okay, so I rarely use Git in a console or terminal. It's actually used more by the other programs that I interface it with. Common, just like the IDEs with R or Python, you can get away with a lot of things that you would have to do in very difficult ways. If you use the source language with no IDE, it can become a lot easier if you use things like RStudio. Okay, so Google Docs, in fact, has what I would call version control nowadays. Word documents also do, but I think a lot of our students are coming in using Google Docs because it's free and accessible. So Google Doc has version control in this way. At the very top right-hand corner of a Google Doc, you'll see this little circle here, and it says last edit seconds ago. And if you click into that page, it brings you to something like this. And I've just taken snippets of this. But the important things are shown. I wrote, this is an example. I waited about 1 minute, and then I went back into my document and wrote, add a second thing. And the important thing here is on the right, it shows not only when those changes were made, but who made them. That's a really great enhancement to where we were before. Also, students could come in and collaborate, and every change is recorded, or almost every change. But it is getting closer to version control. So then what is GitHub? Well, it's a platform, and it allows us, developers or students or faculty, to create, store, manage, and share their code. And it uses Git software. It's going to use Git in the background. So it's also a service, and it hosts what we're going to call a repository, and I'll define that more going forward. And mainly for right now, what that is just files and folders. And it's also a collaboration tool, meaning that all of us can work on it and submit changes, pull changes, add software, remove software, break things, fix things. So in this little picture, we have our GitHub repo or folder in the middle, and we have 3 different students maybe all submitting different changes. And note that they're editing different documents. Say there's only 3 documents. Joey and Matt are both working on document 1 in the list from left to right. Steph is working on document 3. Okay, so they're working on different parts of the project. It also allows something kind of like a forum with what's called GitHub issues, where you can comment on where there's something's broken or not working, or even you can add an issue for something like an improvement to be made for a software, or an improvement to be made for an analysis. You can say, oh, you forgot to, you didn't even consider this variable, and go back and do it again. You can make lists in here. It's used for, it very much looks like a Stack Exchange forum. It's also an app. So you can get the GitHub desktop app. And Maria, thankfully, already showed the Git tab in RStudio earlier. So it's also in RStudio. So you don't actually even need this with your students if they're using something like RStudio because it's integrated in. So this is just showing some of the making of this workshop. It's showing me the changes that I've made, what files are going to be changed when I send this back to my existing repo. So research on using GitHub in the classroom. So I've included a few different really great papers on why that are research-based reasons why you should consider using Git and GitHub in the classroom. This is just a few. These papers come at least once every couple of months. Another research group, there's a lot of overlap too, but are adding to this very quickly building base of research why we should use it. And they all provide really great examples on how to use it and a lot of resources on how you get started. So today's workshop is going to be short, but those places you will find essentially a heap of resources that maybe you'll never read all the way through, which is a good problem to have. So my opinionated reasons to use Git and GitHub. It's free. Coding. I use R. I use a little bit of Python, but mostly R. And about 80% of the classes I teach use R. I don't think if I was teaching a class that had no code, I probably wouldn't use Git or GitHub because it's, as you saw with the red and green a few slides ago, it highlights changes to code. It's not that you can't use it for other things, but that's where I think the utility really kicks in, is you have this really strong version control system that works well with code and a really strong collaboration tool. It's forced collaboration. I say this because when I have my students use it, they feel it. It's more work to collaborate with GitHub initially than if they were to just drop things in a Google Drive folder. But the payout is there. We have to do it to do good research or use something similar or have some organization, and it forces the organization in a way. You can still name things very poorly, but we can go see who named it that way and also when they named it, which is useful. Students make more deliberate choices. So I found when students are interacting with Git and GitHub, or GitHub specifically, they realize there's a little bit more formality than just dropping things in a Google Drive folder. It's tracking when they're doing it, who's doing it, what they change. It's showing every possible thing that you'd want to know about the change made to a file. And so students are more careful about what they name things, when they push things back, when they add things, when they remove things, when they delete things, or when they work on things. I'll tell them, hey, you worked on this at 5 in the morning. Did you get any sleep? And they'll look at me questioning. Okay. Integration, it also integrates into things like RStudio. It also has something called GitHub Pages, which will allow you to take any GitHub repository that you'll see in a workshop and turn it into a website for free. It's also something that is a lot of jobs are looking for, some version control systems students are familiar with. It doesn't have to be Git and GitHub. They are just one of a few, but jobs do look for those things. So what to expect in the workshop is more terminology. There's a lot of terminology with Git and GitHub. I kind of threw some around already. Repo, polling and pushing and forking. There's all these weird terms. Hands-on practice collaboration. I'm going to have you fork a repo, make a change, and then we're all going to push it back and together. You're going to help me fix my typos that you saw throughout this presentation if we have time in the second half of the workshop. And additional options for educators. I have a lot more resources listed. And that concludes my session, my intro session on Git and GitHub. Hopefully I convinced you that maybe it's worth learning more about. And right on time. So I will pass it back, Alan. Thank you.
Thank you very much, Tyler. Thanks to all the presenters, mostly for presenting and sharing your expertise and wisdom, but also from my perspective, thanks for being so prompt and on time. We are spot on time, so thank you very much. We're going to take a break soon, but before we take a break, let me remind you that after break, you're going to choose a breakout room to go to. There's going to be 4 breakout rooms. The breakout rooms will be identified by the tool name and the presenter. So you'll have a chance to choose one breakout room immediately after break. I think we'll stay there 35 minutes or so, and then you'll have a chance to choose a different breakout room for a different tool if you care to, or you can stay in the same breakout room and dive even further into the tool. Before we do that, do any of the presenters want to say anything to help people prepare to enter your breakout session? I think, Maria, you had something in particular.
Yes, I'll put instructions in the chat if you're interested in either one of the R sessions to just go ahead and join the Posit Cloud space. You can log in using a Gmail, you can like kind of register or a GitHub account, and then opening up the activity. So I'll post it in the chat.
Thanks. Any of the other presenters want to have people do anything in advance of joining your breakout room?
Yes, if you want to join my session and want to follow along, you will need a GitHub account. So I'm just going to link the general GitHub website, but please sign up. It's free. Takes just a couple minutes. You have to choose a username. Maybe that's the hard part.
Hunter and Rachel?
It's never come across my experience, but I think it's actually probably true that you need a Gmail account or a Google account in order to like work with Colab, even though it's free. So if you don't have a Google or Gmail account, then maybe set one of those up, but feels like everybody probably has one of those these days. So. Thank you, Valerie.
Rachel, anything?
Yeah, so if anyone wants to join mine, you can set up a Tableau public account. All you have to do is go to tableau.com. I will be patient and I can, if anyone doesn't already set it up, or at least for the second half, if you've already done everything else for another software, that's fine. We'll have time for that. But if you just want to get a head start on it, it could make us go a little faster. And the same thing, you probably would want to use a personal email account just because you may move around and not use your work account after a certain amount of time. So, you know, any other personal account may be better for your Tableau public account.
I know participants probably have questions, but you can ask those questions in the breakout rooms. Remember, at the end of the workshop, we'll have 15 minutes back here in the main room for Q&A. So there's going to be lots of opportunities to get questions answered. Perhaps even more importantly and more fun, lots of opportunities to get your hands on, so to speak, these tools in a breakout room where you've got the presenter / expert to help guide you. So it's 23 after the hour. How about if we take a 12-minute break? Well, first of all, I have another question. So Rachel, you set up the Zoom and the breakout rooms.
Yeah.
Do I just open the breakout rooms and then people can choose them? Is that how it works?
Yeah, so we could basically, you mean after our break, when we come back?
Maybe midway through the break, I'll open the breakout rooms and then
Sure.
people will just be able to, will just show up on the participant screens and they choose one, or how's that work?
Exactly. So here, for example, if we do this now, if I just hit open all rooms, please don't do it now, but now anyone, you can pick your room that you'd like to go to. But there are 4 rooms and I'm going to close them now. But at some point, Alan will be doing that in the middle of our 12-minute break. 11-minute break.
I have to scroll down to find the 4 rooms, but if you have to scroll down, that should be all you have to do.
Yeah.
Okay, I'm going to stop the recording now. After I say thank you again to the presenters and thanks to everyone for being here. So I'm stopping.